Hey everyone, welcome to the Visually Understanding Quantum Computing playlist. You can see here we have already completed 5 weeks, and today we are going to complete our week number 6. And again, today we will go through one more single qubit gate, and then I will answer you the question that I asked you last time. And visualization, of course, of today's gate, the visualization of the previous gates, answering the question, and one more question to end this week. All right. So let's get started. So today's gate will be Pauli Z Gate or the Z operator, and it's represented something like this. Again, as just a box written with the written Z in it. Now, the matrix that denotes Z is this that you can see on your screen. And let's again do that our standard computation of applying Z to 0 and then Z to 1. So first we'll start with applying it to 0 kit and see what happens. So again substituting the matrix, this matrix for Z and 0 kit, alright. Then we just carry out simple matrix multiplication and what we get is this. And if you just write it in direct notations, you can see it's just 0 ket. So when we apply Z on the 0 ket, we get 0 ket again. So is this something like identity or something? Let's just watch this. Now let's do the second part, applying Z operator on the 1 ket and see what happens. Do we get 1 ket again or something else? Okay, substituting the matrix here in place of Z and writing 1 ket, alright. Again, the simple matrix multiplication, nothing much to explain. Then we write this vector creatively by taking -1 out and then writing it this way. So, and we do this to just write it in a direct notation. Now you can see when I applied this Z ket on Z operator, sorry, on the 1 ket, I get 1 ket, but I have this minus sign along with it. So now this signs are very crucial part, and it relates to a concept of phase, uh, global phase, relative phase, and phase feedback, such concepts. But I will go into it sometime later. But now today, let's get to the visualization of the Z gate, the Pauli Z gate, using quantum glasses. That our tool. And if you are new to here and you don't know what is this quantum glasses, you can check the first video from the playlist, and it will help you to get the quantum glasses for yourself. Okay. So I want to apply it on the 0 ket. So just a direct Z will do. And if I visualize this, you see nothing happens. The vector stands still. So what happens is when you apply Z on the 0 ket, you will get 0 ket. So there's no transition at all. And that's what the quantum glasses is indicating here. So let's try the other way around now. I apply X gate first, the quantum NOT gate, to change the state of the qubit from 0 to 1 ket. And then I will apply Z. Okay, so this is equivalent to applying the Z operator on 1 ket. Now let's visualize. So of course, the first we will see this effect. That will be, the X gate will take this qubit from state 0 ket to state 1 ket here. But let's see what happens next, because we had that minus sign, so we were not getting directly 1 ket. But you can see that it still just held there. It just stays there on 1 ket. So even there was no difference. So that minus sign doesn't make much of a difference there. All right. And we will see that the concept more very clearly when I just take that video on the phase. Okay, but you can see that minus sign is not affecting it here. So does this mean that this Z gate is totally useless, like it's not having any effect at all? That's not certainly the case, and I will tell you now. And I will not tell you, I will show you. So I'll just apply the Hadamard gate, the H operator that we have studied, and then I will apply H. And let's see if something happens this time. So you can see now Now it's just the effect of the Hadamard operator, the H operator, and it will bring the arrow here, the state here near where you can see X written over here. Then let's see what happens. Now, yes, now you can see that Z is written over here, so it's the effect of the Z operator, and the state is actually moving. It's not standstill. And yes, it will end over there. So what just happened over here? So to this week's question will be for you, assignment question, whatever you think. You already know this state here, the plus state. So try to apply the matrix of the Z gate on the plus state and see what you get. So that this week's assignment for you. And now let's understand what this Z gate is actually doing here. So you know what? The Z gate can rotate the state vector by 180 degrees only in the plane which is perpendicular to Z axis. So if you see here, uh, this zero cat is the zero cat uh, is not in the zero cat state vector, which was initially the state of the qubit, was not in the plane which is perpendicular to the Z axis. All right. So let me just rotate this here. Now, this plane that you see here, when I rotate this above, which makes look 0 cat and 1 cat coinciding each other, this is the plane where a Z cat can have any effect, all right? It can only move a vector by 180 degrees when it's in this plane, okay? So when you saw that the 0 cat and 1 cat both were not, are just unaffected by Z cat, Z operator, sorry. So that the reason was that both of those vectors were actually not in this plane, okay? Both of them were in different planes. That's why it was no effect of Z gate. Again, if you recall last time, we saw that for the X operator as well as the Y operator, both were having the same effects, okay? They were just taking the 0 cat to 1 cat and 1 cat to 0 cat. And I told you to pick up the difference visually. If you okay, let me tell you, let me just show you again. Let's clear this. uh, let's just apply a simple knot. If you notice here, the plane in which this is moving, this is the plane which is perpendicular to the x-axis. So the Pauli X gate will rotate the vector by 180 degrees, or if and only if that state vector is in the plane which is perpendicular to x-axis. All right. Now, I think that is clear, right? 0 cat to 1 cat. This plane, rotation of this plane was perpendicular to x-axis. Now, if I close this and if I just apply y, you will see that the plane will be different here. You can see the plane here is now perpendicular to y-axis. So that's the difference. The plane of rotation is different for x and y operators. All right. That's a big difference. So if the state vector is not that in that particular plane which is perpendicular to that particular gate, poly z x or y, then that particular poly operator will not have any effect over it. All right, that's what we have seen visually. And that's it for this video, and I hope you will try to do that assignment that I just gave you. And if you're still not clear, watch the first video, get yourself quantum glasses, do some crazy experiments with it, and rewatch this video if you have not yet understood. But I will meet you next time in the next video. And until then, take care.